Hi, my name is Cody Tuttle, and my project was Big Data Case Study in Natural Language Processing, Improving Search. So the first question is, what is natural language processing, or NLP? Natural language processing is an area of computer science focused on the ability of machines to understand human language. Although work in this field began several decades ago, it's only in recent years that NLP has shifted to a data-driven approach. With increased computing power and improved mathematical methods, NLP adopted a statistical paradigm in the 1980s. Now, as the ability to store and analyze big data becomes more commonplace, NLP is becoming the next step for many technologies. Yahoo recently spent $30 million to buy a company named Sum.ly that uses NLP techniques to automatically summarize articles. Google spent a similar amount to buy Wavy, a company that uses NLP to group and distribute news articles. IBM's Watson, Apple's Siri, Facebook's Graph Search, and Google's Web Search all leverage the power of predictive analytics and huge sets of data to process human language in a meaningful way. While the ability to store a seemingly infinite amount of information has led to incredible technological advancements, it's also made good search techniques imperative. So right now we're faced with an information overload. We need to process this big data and return it to humans in a meaningful way. It's no longer enough to return results that simply contain the search term. Rather, we need to interpret the search word or phrase and return results that are the best match. This is especially true in cases where the user is not exactly sure what he or she is searching for. Just a few days ago, for example, I read an article about a giant East African snail that was found in Florida. Today, I could barely remember any of the details, so I searched Snail USA, and the third result was Florida battles slimy invasion by giant snails. Now that's Google's magic at work, which involves a degree of NLP, such as searching for synonyms of the term the user submits. Google, however, is kind of a rarity. As the information we store continues to expand, it's important that companies spend considerable resources on developing mechanisms to search that information. Imagine 40 years in the future, when all our lives are recorded through Google Glass, all our appliances store logs of usage data, and our biometric information is recorded every hour of the day. Having all that data would be amazing, but only if it can be accessed in an intuitive and easy way. So what is Google's role in NLP? Google currently implements NLP methods in its search and is continuing to make contributions to the field through research and products. A quick glance at Google's research page for NLP reveals a few interesting topics, such as using social media posts to determine user location and tagging parts of speech in languages other than English. In terms of products that they offer, they have an n-gram corpus that stores n-grams from books back to 1900s, 1800s, all the way up to today. They also have Google Now that was just released, which is Google's answer to Apple's Siri. And they recently had that acquisition of the company Wavy that I mentioned before. So, to recap a little before we move forward, NLP is a growing field and will only continue to improve with the size of data and our ability to analyze it. Further, NLP can be used to piece through the ever-expanding pile of information we store, and influential companies, such as Google, are investing time and resources to develop NLP-based products. So now, you have to wonder, if NLP is so great, how do I go about, getting involved? And so, one of the big tools for NLP right now is something called the Natural Language Toolkit, which is a package for Python. It is used frequently by researchers, and it comes bundled with many corpora, or natural language data, and offers several powerful functions for cleaning, parsing, and analyzing natural language data. NLTK, Natural Language Toolkit, has functions that eliminate stop words, lematize the data, tag parts of speech, tokenize the data, and cluster the data, and many more types of functions. The problem is that NLTK does not easily transmit to a MapReduce framework. So even though Amazon Web Services offers Hadoop streaming, where you can submit Python programs, it's difficult to convert NLTK-based programs to map and reduce classes because the functions are prepackaged. For that reason, NLTK isn't ideal for analyzing huge sets of data. In class, we were briefly introduced to Mahout, a command line program that comes packaged with several predictive analytics algorithms in MapReduce format. For my demo, I explored the capabilities of Mahout. I use Mahout to cluster a subset of emails from the Enron email dataset and return a vector of similar emails for every email. I also use that vector to demonstrate the power of NLP for search through a website. So the problem with Mahout, though, on the other hand, is that it doesn't have as strong of a core for natural language processing. It's kind of a general predictive analytics tool, whereas Natural Language Toolkit is honed in on natural language processing. So it's kind of a give and take. But if you want to analyze huge sets of data, Mahout is the better tool. Just a quick overview of the demonstration before we move on. So the idea here was to take a subset of emails from this Enron email corpus and cluster them and return 5 or 10 emails that are the most similar to other emails. So every email would have its array of other emails that are most similar to it. Do this through a bag of words approach, which is where you turn the email into a vector of the frequency of each time each word appears in that email, and use Mahout's row similarity command, which I'll show later. And the data is from the Enron email corpus, which is this huge swath of data released back whenever the Enron email scandal was happening. And I think it's about 600,000 messages in total, but I use around 1,500. So, coding the demonstration. I provide explicit details on how to go through this in the documentation document. And there's full code in a folder attached called full code. But I'll briefly go over it in this presentation. So after downloading the email data, you can transfer it to Hadoop's file system on your virtual machine, and then begin to work with it from Mahout in the command line. Then once you run the predictive analytics in Mahout, you output the data, and the results from Mahout are going to be really messy. And so I use Python. You could use any language really to clean it and put it in a CSV format. And I uploaded that CSV to a MySQL database and used HTML, PHP, and D3.js, which we learned about last class, to build a website that displays the results. Here we can take a look at the Mahout code. So this first piece right here, Mahout seek directory, takes the directory of email files and turns them into a sequential directory file. This second piece then takes that file, that output from the top, and converts it into vectors using bag of words. This org.apache.lucene analysis whitespace analyzer tokenizes the words based on whitespace in between characters. This weight term frequency inverse document frequency weights the words based on how often they appear in the documents and across documents. So for example, the word the would have a low weight because although it appears often in a document, it appears in all documents. This x80 command tells it to drop any words that appear in 80% or more of the documents. So that's kind of the equivalent of getting rid of stop words, which are common words. And this NV right here stands for named vector, which will allow us to see the file names after we cluster in later steps. And so here's the k-means clustering algorithm. K-means, you use it on your term frequency, inverse document frequency, weighted vectors. For this exercise, I use the cosine distance measure because it has this unique property where document length doesn't really matter for determining similarity. And I think that's good when you're searching through emails. And this K10 option specifies that we want 10 clusters. Here we run some other code to find the similarities. We use row ID and put the vectors into a matrix. and then we use Mahout's row similarity command to calculate similarity cosine, again, on this entire matrix, providing the 10 most similar documents. Then we can output all those results with Mahout's seek dumper command. So here's a screenshot of the website. I first put some MySQL searching functionality so we could compare it to what we get from our similar document search. So MySQL offers some commands that will kind of do a fuzzy matching against the database and search for things not just in the search term. So instead of just searching for hiring, it might also search for hire. So here's one result from there, and you can see that the word hiring is in the result, and I'm not just showing you something that confirms my hypothesis, but all of these results here contain the word hiring. And so now we can see a screenshot of the website using the similar documents approach, and I search for hiring, and then the first most similar email to an email that contained the word hiring is this: offers from June 3rd, Super Saturday for your information. The spreadsheets attached below list the candidates from the June 3rd Super Saturday who have been made offers. All of the candidates have been contacted. Thanks again for your participation. So it sounds a lot like an email about hiring, but it doesn't contain the word hiring. Yet our method still returned it, which I think is good and is one of the advantages of NLP searching. So, in conclusion, NLP is a growing field. It's supported by influential companies like Google, Yahoo, Facebook, Apple, IBM. And improving search is increasingly important with all the information that we store. And the great thing is that it can be done quickly and easily with Mahout. Thank you.